Okay, hi everyone. Um, so just a short update on today's work. It's really just going to be the IXL on what we've been talking about, removable discontinuities. But there's some problems here I just want to go over the style that so I can just make sure you guys are all okay with this. So if you look at this problem here, like normal, what our goal is to see what the limit is by just first skill is to just plug it in. So if I did plug in the 0, we end up with negative 2 squared minus 4 over 0. And that's 4 minus 4 over 0 is 0 over 0. That is indeterminate. That means you have to try another way. Now for this type of problem, it's actually fairly easy. Like, we look at the problem and we say there's no special fractions, no tower of terror, there's no radicals in it. So in this one, we're actually just going to multiply out this guy here. Now, how did I know that? As I know that, first, if I plugged in the 0, it was not going to work. But the trick here is actually this guy here. If I look at the back, what is negative 2 times negative 2? That's give us a positive 4. And the positive 4 is actually going to cancel out with this negative 4 here. And that'll actually clean up the problem. So we're going to actually multiply that out. And if you remember how to square a binomial, let me give you an example. If it's a plus b squared, you square the front, you square the back, and you double the middle values, whatever they may be. So giving us values, numbers, let's say it's going to be x plus 3. We square the front, becomes x squared. We square the back, becomes 3 times 3 is 9. And we double x and 3 when we're multiplying them together. So a fast way of saying that, 3x times 2 is 6x. So we have a fast way of doing it, okay? So for the top problem, I see negative t minus 2 squared. We're going to go ahead and rewrite the limit. Oh, sorry, t approaches 0, I'm sorry. T approaches 0. And we're going to go ahead and square that negative t minus 2. That becomes t squared, square the back, plus 4. And we double the middle, which was going to be a positive 2t, so it's a positive 4t. And minus 4 all over 3t. Now again, this 4t is just me copying that. And how do I get the t squared plus 4t plus 4? That is us distributing that part here. Now if you notice, as we talked before, we want to get rid of that plus 4 and minus 4. And that simplifies out to a limit as t goes to 0 of t squared plus 4t over 3t. Now, if I try plugging 0 right now, 0, 0, 0, because of the limit, we would still get 0 over 0. And it's because we haven't gotten rid of the offending value yet. Our t is equal to 0. So let's go ahead and factor out the t to make this really obvious. I see there's a t on top. 2 t's, I'm sorry. Limit as t goes to 0 of t plus 4 over 3t. And then if I divide out the t's, we got rid of that 0 over 0. Remember, t was 0. This was my 0 over 0, and we got rid of it by dividing it out. That was our whole. And we're limit of rewriting this, showing all the work. Limit as t approaches 0 of t plus 4. Don't forget the 3 is on the bottom. Plug in the 0, we end up with 0 plus 3, no, 0 plus 4 over 3 is 4 over 3. Let's go plug in our answers. Oh, it won't let me plug in it. Okay, but all right, let me go get rid of that. We're done with this. And we say our answers was 4 over 3. Oops. Okay. The follow-up question is very similar to the last one. If I plugged in 0 here, let's go ahead and do the same thing. If I plugged in 0 here and 0 here, we end up with negative 3 squared minus 9, which is just 9 minus 9 is 0, and we see 0 over 0 because the bottom would have been 0. Okay, indeterminate, we got to find another way. And in this method here, we're just going to say, hey, if I did square negative 3, right, if I did square the negative 3 in the back, that would give us a positive 9. And wouldn't that get rid of that negative 9 here? So maybe that's what I'm going to do. So we write the limit, rewriting the problem, as x approaches 0. And let's go ahead and multiply out our negative 3x minus 3. That becomes negative because of positive 9. X squared. 3 times 3 is 9. So that's double it, becomes plus 18x. And we're going to say plus 9 and then minus 9 all over negative 2x. Now again, just to show you guys where I'm getting these numbers from, the negative 9 is back here. And we squared the negative 3x minus 3, and that gave us the 9x squared plus 18x plus 9. We have some common, like terms here, like terms. Those simplify out to become the limit as x approaches 0 of 9x squared plus 18x all over negative 2x. We see a common x. Let's go and factor that out. We also have a 9 there. If you want to factor that out too, that is not going to be a problem. Plus 18. We can divide our x's. The limit as x approaches 0 of 9x plus 18 over negative 2. We can divide that out to become, nope, actually we're done. Okay, let's go ahead and plug in our 0 now. 9 times 0 plus 18. Now again, please be advised, as I mentioned before, we always have to keep writing limit until we plug it in. Once I plug it in, I didn't write limit here anymore. That's going to be 18 over negative 2, which is negative 9. Now let's look at this as a graphing version. My answer is negative 9. So I want to see, can I pull up another... Let me split window this. I can. All right, let's go to Desmos. It's there already. And we're going to go ahead and graph our graph just to make sure this works. Just to show you guys. Let's do 2 of these. X, I'm sorry, negative 3x minus 3, close it, square it, minus 9. We're divide this by 2 negative 2x. So what would the value look like at when x is 0? Let's take a look here. When x is 0, our y value would look like negative 9, right? See, it has negative 9. But once I get to 0, it's actually undefined. Because remember, there's a hole there. But doesn't it look like, look at the y value. Doesn't that look like negative 9? Pretty close to negative 9. And that's what the limit told us. Negative 9. Okay, now, as we go about the rest of these problems, a lot of them are just pretty much reviews from before. And we'll see factoring problems. And we'll see radical problems. And we go ahead and practice those, okay? All right, thank you very much.